Assalamualaikum and hi everyone. Today we are going to learn subtopic 5.3 inverse function. For inverse function, if fx maps to y, then the inverse function is denoted by inverse of f, where inverse of f is function that maps y back to x. We can look into the arrow diagram when x maps to y, so we can call it as fx. And when y back to x, this is what we call as inverse of x. Suppose fx equal to y, then inverse y equal to x. The domain function is equal to range of inverse function, and range function is equal to domain of inverse function. Also, we can note that inverse function of x is not equal to 1 over fx. Properties of inverse function. An inverse function of f exists only if the function is a one-to-one function and onto function. Method to test whether a function is one-to-one function is algebraic approach and horizontal line test. Algebraic approach, we can start with let x1 and x2 must be in real number. If substitute x1 and x2 into fx function, then the result gives you x1 equal to x2. We can conclude that fx is one-to-one function. Second method is horizontal line test. If the horizontal line test intersect the graph of given function only one, then the function is one-to-one function. For vertical line test, we can use to test whether we have function or not.
Inverse function by using the formula. The formula is f of f inverse x equal to x. So we need to remember this. Here we have three notes. Firstly, f inverse equal to f. Next, f inverse composite fx equal to positive x. And for this, we can change the places like f composite f inverse x. But make sure this is must equal to positive x. The last note is f of g inverse equal to g inverse of f inverse. Next, fx equal to s minus 2 square minus 1. This question in completing the square CTS. So, we no need to expand. For this question, we just replace x to be f inverse. F inverse x minus 2 square minus 1 equal to x. And simplify until we get f inverse as our subject. To know our sign positive or negative, we should look our condition. Conclusion, since x must be more than or equal to 2, f inverse equal to plus third x plus 1 plus 2. This question, we can choose either algebraic method or graphical method. For this, I use the graphical method by using the horizontal line test. Firstly, we need to know our asymptote. So, x over 3 minus 1 must be greater than 0 and simplify until we get x greater than 3. Next, we can sketch our graph that asymptote at 3 but cannot touch 3. When our line touch x exists, we need to search y-intercept when x equal to 0. Ln times x over 3 minus 1 equal to 0. X over 3 minus 1 equal to exponential 0. Remember, exponential 0 is 1. So, x over 3 equal to 1 minus 1 is 2. So, we get y-intercept is 6. Conclusion, since horizontal line test cuts at 1 point, fx is one-to-one function.
Let's continue with 5.4, exponential and logarithmic functions. So I want to talk about exponential function. These are properties of exponential function. The first one is when a is greater than 1. When x equal to 0, then substitute a equal to 0, so the function would be 1. When x extends to positive infinity, the function would be positive infinity. and when x extend to negative infinity, the function would be 0. The second property is a between 0 and 1, and as x equal to 0, the function would be 1. When x extend to positive infinity, the function would be 0. When x extend to negative infinity, the function would be infinity. So the graph have quadrant 1, quadrant 2, quadrant 3, quadrant 4. Quadrant 1 when x positive, y positive, and so on. The general formula for exponential function is y equal to positive e a x plus b plus c. So we look at the question. Fx equal to e the power of 3x minus 7. So let x equal to the inverse of x. X equal to e the power of 3f minus 1 minus 7. So we put ln each side. So we can, so in multiply with e, we got 1. So 3 the power of f minus 1 minus 7 equal to ln x. So the final answer is inverse function x equal to 7 plus ln x over 3.
This is logarithmic function. The properties of logarithmic function is fx equal to log x base a. A must greater than 0 and a cannot be 0. When y equal to positive ln and positive x in first quadrant, because ln and x are positive. Okay, y equal to positive log bracket ax plus b. Positive log is a sign of y and in the bracket is sign of x. There are 3 tips to solve the equation. First, we must search q. Q is for quadrant. Second, we must search I for x-intercept. And finally, we must search A. A is x-asymptote. So we look at the question. Fx equal to ln x plus 3. Find domain and range. First, we must search q. So the q is q1, quadrant first. Second, we search x-intercept. We take ln x plus 3 equal to 0. We transfer the ln into the other side and we get e the power of 0 equal to 1. So x plus 3 equal to 1. We settle it and get x equal to negative 2. Then we search x-asymptote. X plus 3 greater than 0. X greater than negative 3. So that is the graph. We must search y-intercept because the graph touch the line y. So we do x equal to 0. If f 0, ln 0 plus 3, ln 3 equal to 1.1. So the domain is negative 3 to infinity and the range is negative infinity to infinity. That's all from us. Thank you for watching. Bye.